So here we have it, OpenAI Real-Time API integration. Hey everyone, we are back. So we're diving right into OpenAI's real-time API and Livekit integration. Here's a quick description. OpenAI's real-time API is a WebSocket interface for low latency audio streaming, best suited for server-to-server use rather than direct consumption by end user devices. Livekit offers Python and Node.js integrations for the API, enabling developers to build real-time conversational AI applications using Livekit's agent framework. This framework integrates with Livekit's client SDKs in a telephony solution, allowing you to build applications for any platform. It sounds like it's a framework that we can utilize to speed up our development process when we're developing AI agents. Here's a quick graph that they provide for us. So here it explains that we have our client, so it can be a web application, it can be a mobile application, or simply a phone. Here we have the Livekit cloud infrastructure. We're going to be communicating with that Livekit cloud server via our client. We have a web RTC protocol that's going to allow Livekit's cloud server to communicate with our backend API. Our backend API, we can consider that our agent. That agent is going to communicate with the OpenAI real-time API server. So essentially, the OpenAI real-time API server never directly communicates with the Livekit server. Instead, it utilizes our backend as a proxy, both with the WebRTC and a WebSocket. Our backend also doesn't communicate directly with our front-end client. Normally, that's what we would see in a traditional application, but in this case, we're going to have the Livekit cloud server communicate with our client, and that's going to be the interstice sits between our backend and our client. It's going to be the Livekit cloud server. WebSocket is not ideal for real-time audio and video over long distances or slower networks if you have bad internet connection or you're speaking to someone in a completely different country. Livekit bridges this gap by covering the transport to WebRTC and routing data through their global edge network to minimize transmission latency.
You're utilizing their infrastructure, Livekit, in order to bridge the gaps in communication between you and the other party. So here, even though you have poor internet or you're simply really far away from the person that you're trying to communicate with, or maybe you're just far away from a server that's hosting the OpenAI. Well, in this case, we want a way to streamline those packets that we're sending in order to have this TCP IP transfer call protocol. So the only way to do that is to leverage either a content delivery system or content delivery network, CDNs is what they're called, or you can go ahead and utilize a third party, which will allow you to transmit those packets much more faster through their own protocols. And that's what we're doing here in order to strengthen that connection. That way, we don't have latency when we're speaking to the large language model. The agents framework. The agents framework provides everything needed to build conversational applications using OpenAI's real-time API, including support for Python and Node.js, client SDKs for nearly every platform, inbound and outbound calling using SIP trunks, WebRTC transport via Livekit Cloud or self-hosting OSS, worker load balancing, and request distribution. So I think this is where we're hitting sort of that distribution so that our packets are sent utilizing the Livekit infrastructure. Here we have Livekit concepts. The Livekit agents framework uses the following concept: room, a real-time session with participants. The room acts as a bridge between your end user and your agent. Each room has a name and is identified by a unique ID. Participant, that's number 2. A user or process, example given, an agent, participating in a room. So you can imagine you have a room, you have participants, and those are the two that we're pointing. Very simple at this point. Agent, a programmable AI participant in a room. This is essentially just the AI. Some people call it agent, some people call it assistant. It's up to you. Track, this is the 4th one. Track, audio, video, text, or data published by a user or agent and subscribed to by other participants in the room. Here, we have a multimodal agent. The framework includes the multimodal agent class for building speech-to-speech agents that use the OpenAI real-time API. To learn more about the differences between speech-to-speech and voice pipeline agents, see voice agents comparison. So we're going to go ahead and run a demonstration of this project so that you guys are chomping at the bit to get started on your own project.
If you haven't subscribed by now, please do so. Click that subscribe button right on the side. Join this tech family.